Hey everybody, happy to have you here with me. Let's take a look at chapter 9, section 2. Today you'll be finding coordinates of points on the unit circle. Very important stuff, especially in future math classes. Finding trig values for key angles of sine, cosine, and tangent. So, let's grab your notes. Let's go ahead and get started. Our unit circle, it's a circle with the center at 0, 0. So here it is at our origin. Our unit circle, it's called the unit circle because our radius is 1 unit long. So if I were to look at my circle and knowing that my radius is 1 unit, so this is 1 unit long, that puts me here at this point, which would be 1, 0. If I went up 1 unit, well, there's my radius of 1. This would be the point 0, 1. Yeah, these need to go in your notes. We're going to use these a lot. Over here, if we went to the left 1 unit, well, when you go left on your x-axis, that gets you into negative territory. So that makes this point -1, 0. And if we went down 1 unit, well, that would make 0, -1, because y's are negative here, x's are negative here, x's are positive, y's are positive. Think of your xy plane. Now, because we have a radius of 1, any triangle, any right triangle made by the unit circle has a hypotenuse of 1. So if I were to draw a unit circle and then I draw some triangle inside, a right triangle, well, here's my triangle. Goes straight down to the x-axis, and over here I have an angle. I have a 90-degree angle. My radius is 1. Now, as I'm looking at this triangle, this would be my x distance, however big that is. This would be my y, or my height, because y's go up and down, x's go left and right. And we're going to use that triangle to help figure out our angles for sine, cosine, and tangent in a few minutes. So let's take a look at the best website in the world. It's called Math is Fun. I'm sure you spend lots of time there just like I do, right? Oh yeah, who doesn't go there all the time? Math is fun. And they start off talking about the unit circle with a radius of 1, just like what we had. Look at those key values, 1, 0, 0, 1, -1, 0, 0, -1. Very, very important stuff. They give you some information about sine and cosine and tangent. We're going to pass over that, and we're going to take a look at the interactive unit circle. Our unit circle, turning on my quadrants, we have right triangles. As the angle moves around, you can see inside we've got a right triangle. And that right triangle always has a right angle up to or down to the x-axis. But as my angle goes from 0 degrees up to, say, 30 degrees, you'll notice the numbers for sine, cosine, and tangent are changing. The height keeps getting bigger and bigger and bigger. The width of the triangle gets smaller and smaller. At 45 degrees, we have the same answers, 0.707 for sine, 0.707 for cosine, and you'll notice tangent is equal to 1. As we bump up to, say, 60 degrees, okay, well, the height keeps getting bigger, the width keeps getting smaller. And you might have noticed that 30 degrees and 60 degrees, they have some answers in common. Think of your 30, 60, 90 right triangles. At 90 degrees, well, we got kind of an odd situation here. We have no width, which is why your cosine is 0, but we have a height of 1 because the radius is 1. Versus back here at 0, we had no height, so our sine is equal to 0, but we have a width of 1 unit. And if I go all the way around, you'll notice sometimes they're negative. We'll talk about that in a minute. Sometimes they're both negative, and it just depends till we get back to a full circle. So now that we've had a little fun with the best website ever, let's continue on. With our unit circle, there are some key angles that we're going to have to know off the top of our heads. For instance, this is 0 degrees. But if I go a complete full circle, it's also 360 degrees. So when I say 0 degrees or 360 degrees, I'm referring to being right here. Depends on if I didn't go anywhere or if I went a complete full circle. Every circle has 360 degrees. Which means if I did half of a circle, well, that would have to be 180 degrees. And if I only want half of a half, well, half of 180 would be 90 degrees. Notice that they make a right angle here, your x and your y-axis. That's why it's a 90-degree angle. So how about down here then? What's this angle? Well, I could take 90 plus 90 to get 180 plus 90 more to end up at 270 degrees. 90 more makes a complete full circle. And what we're looking at in here is creating a right triangle. Right. Whew, that was rough. I was doing good until I started coming straight down there. Let me try that again. Hard to draw on this thing. It'll have to do. There's our right angle. Here's the angle that we're interested in. We usually call that like x or theta. Theta is a Greek symbol we'll see in a few minutes. Radius is 1, so the hypotenuse is 1. This is my x, this is my y. So far so good? And we've said that we've got some points here like 1, 0, 0, 1, -1, 0, and 0, -1. Well, the thing that we have to understand is when we start drawing a right triangle, we're thinking trigonometry. So what we know about trig so far is, that's right, SOHCAHTOA. SOHCAHTOA, 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 SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. SOHCAHTOA. So if I have some angle theta, and I want the sine of angle theta, that's the symbol for theta. It looks like a 0 wearing a belt. That's our Greek symbol, theta. T-H-E-T-A, theta. Well, that's opposite over hypotenuse. So looking at our triangle, opposite would be y, hypotenuse is 1. Y over 1, which is simply y. Let's think about cosine. Cosine of theta, cosine is adjacent over hypotenuse. And if you look at your unit circle, the right triangle, adjacent, here's my angle, adjacent x, hypotenuse 1. So x over 1, anything over 1 is itself. Tangent, opposite over adjacent. So tangent of angle theta would be opposite the y divided by adjacent the x. So look at what we have. Y divided by x. Y is sine. X is cosine. So another way to think about this, we can say that tangent of theta is equal to our sine of angle theta divided by our cosine of angle theta. We use that one a lot. Okay? If we can find our answer for sine and our answer for cosine, we just divide the two, we have our answer for tangent. So, knowing that, let's take a quick little brain break. Nothing you need to write down here, but I thought you might enjoy this. If we have sine of some angle called gerene, and we have cosine of some angle called gerene, what do you get? Sine divided by cosine is, that's right, tangerine. It's kind of like an apple, but not as good. And how about this one? Again, nothing you need to write down, just a little funny for us. Sine of b divided by tangent of b. Well, I don't know, but I do know that tangent of some angle is sine divided by cosine. I'm looking for sine divided by tangent. So if I were to cross multiply, let's see, tangent of b times cosine of b equals 1 times sine would be sine of b. And now I could divide both sides by tangent because I'm looking for sine divided by tangent. So let me divide both sides by tangent. There's my sine divided by tangent. Here's my tangent of b. And what do you notice about tangent of b divided by tangent of b? They do cancel. So sine of b divided by tangent of b is equal to cos b. This is Bill Cosby. It's math humor. It's better than no humor at all. Oh my goodness, no joke. We're going to find all these different values for sine, cosine, and tangent of 0, 90, 180, 270, and I might as well say 360. It's not up here because it'll be the same answer as 0 degrees. So, where do those answers come from? They come from your unit circle. Think of this point here. This is 1, 0. And think of how many degrees that is. 0 degrees. This up here at 90 degrees is 0, 1. Notice I keep repeating these because they must be super duper important. Over here, how many degrees? Yep, 180 degrees. And my point would be -1, 0. Down here at 270 degrees, what's my point? 0, -1. Those are your answers, guys and gals. We know that sine is the y, cosine is the x, and tangent is y divided by x. So putting it in perspective, here's what it means. You have points, x, comma, y. X is the cosine, y is the sine. So alphabetical order, x comes before y. When we have an ordered pair, xy, 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 and that means that we have cosine followed by sine. Alphabetical order. Cosine is the x, sine is the y. Cosine comes first, sine is second. 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 These are the answers. 1, 0, 0, 1, -1, 0, 0, -1. Those are the answers staring at us all along. Cosine comes first, sine is second. So let's try to find some of these answers. Sine of 0. Well, cosine comes first, sine is second. So if you're thinking the answer is 0, you're right. Cosine of 0. Cosine comes first, sine is second. Cosine comes first. 1. 90 degrees. Well, here's 90 degrees. Sine of 90. Cosine comes first. Cosine comes first. Sine is second. And you might be saying, well, why did you write sine then cosine if cosine comes first, sine is second? Because that's going to help us when we get to here. Okay? If you look on your calculator, your buttons are sine, cosine, tangent. That's the order your buttons are on your calculator too. Sine of 180 degrees. Here's 180. Cosine comes first, -1. Sine of 180 degrees is 0. Go down to 270, see if you can come up with the answers. Cosine of 270, sine of 270. Cosine is first. Sine is second. So now, what do we do to get tangent? Well, we use our ratio. Y divided by x. Sine divided by cosine. Sine divided by cosine. 0 divided by 1. 0 over 1, that's 0. How about tangent of 90? Sine divided by cosine. 1 divided by 0. Oh, radar's going off. Dividing by 0. We're not allowed to divide by 0, so this is equal to undefined. Why? You can't divide by 0. Okay? Tangent of 90, not allowed. There is no answer. It's divide by 0, not allowed. Graphically, if you were to graph tangent, go to 90 degrees, you would have a vertical asymptote at 90 degrees because you can't divide by 0. Tangent of 180, we want sine divided by cosine. 0 divided by negative 1, that's 0. 0 divided by anything but 0 is 0. Tangent of 270, we want sine divided by cosine. Negative 1 divided by 0. Oh, another undefined. Cannot do it. So tangent has a lot of asymptotes. Asymptote at 90, asymptote at 270, and every additional 180 degree value past that. So, if you haven't put in your notes yet, you need to put this in. This is really the key right here to understanding your unit circle. You have x comma y, that gives you cosine and sine. From there, we can figure out all of our sine and cosine values. Homer and Lisa are sitting there and she's talking about pi and he's going, pi. You like that one? Here's another quick little brain break for us. I'm a math teacher. Of course I have problems. Right. All right, so you guys in groups are going to spend a few minutes, about 20 minutes, working on your unit circle basics. Once you're done with that, you need to pick up your notes and finish up where you left off. I'm going to go ahead and do that now, so you can pause your video and you can come back in a few minutes. How do you know when sine and cosine will be positive or negative? If we're looking at our interactive unit circle on my favorite website, Math is Fun, I'm hoping we can figure it out. For quadrant 1, when I have an angle in here, what's going to happen with my values of sine and cosine? For angle 2, what's going to happen when my angle is here, angle quadrant 3, or quadrant 4? So each of the different quadrants, what happens when those angles are in those particular areas? Let's see if we can figure it out. Okay, so focusing on quadrant 1. Here's quadrant 1 over there to the right. What do you notice about your values for sine and cosine? In fact, I'll even turn on the quadrants just so we can see. What do you notice about your answers for sine and cosine? Positive or negative? They're all positive. Here's why. Cosine is the x. Well, x is positive here. Sine is the y. Y is positive here. Think of your x and y axis. Cosine is the x value. It's how wide your triangle is. Sine is your height. It's your y. X is positive, y is positive. Therefore, all your trig functions are positive in quadrant 1. Even tangent, because a positive divided by a positive would still be a positive. Let's move to quadrant 2. So we have angles that are between 90 and 180 degrees. Looks like sine is positive, 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 but cosine is now negative. How come? Well, again, this is your x, that's your cosine, and x is negative over here. So any angle on this side is going to have a negative answer for cosine. but it's still going to have a positive answer for sine because our height is positive, our y value is positive. If we go to quadrant 3, oh my, both sine and cosine are negative. X is negative, y is now negative. So sine and cosine are both negative. And then in quadrant 4, you'll notice now sine is negative because you have a negative height, that's the y value, and cosine is positive, so all of your cosine angles are positive all the way from 270 degrees back to 359 degrees till we hit our 360 and we're back to where we started from. So, what's an easy way to remember that? In quadrant 1, all your functions are positive. In quadrant 4, only cosine is positive. In quadrant 3, only tangent is positive. That means sine and cosine are negative. And in quadrant 2, only sine is positive. So that means cosine and tangent would be negative, but sine's positive. So I think about it as our ACTs. We've been studying and practicing all year long for our ACTs. If I give you an angle here, the sine of that angle is negative, the cosine of that angle is negative, but the tangent of that angle would be positive. If I give you an angle up here, okay, sine, cosine, and tangent are all positive. What if I give us an angle over here? Who's going to be positive, who's going to be negative? Well, let's see, in this quadrant, sine is positive, but that makes cosine and tangent both negative. One more. Let's say we are down in this quadrant. Who's positive? Cosine. So who's negative? Sine and tangent. Using our special right triangles, we should be able to find our values for sine and cosine of 45 degrees. If I think about my different angles, 45 degrees, well, let's see, this is 0 degrees, this is 90 degrees, so where's 45? It is halfway in between. So halfway in between, we draw our right triangle. This is 45 degrees, which makes the other angle 45 degrees by default, right? Which makes this what kind of a triangle? 45, 45, 90. It's a 45, 45, 90 special right triangle. It's an isosceles right triangle. We have side, 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 radical 2. All right, so our radius or hypotenuse is 1. So we have side, I guess I'll call that a side, which makes that a side. They're the same. It's a 45, 45, 90. That's a side, that's a side. That's equal to 1. So somehow, we got to figure out these two remaining sides. We could do Pythagorean theorem. We could set these two equal to each other and solve for s. Well, let's just do Pythagorean theorem. We're pretty comfortable with that. A squared plus b squared equals c squared, yes. So s squared plus s squared equals 1 squared. I'm feeling extra helpful. I'll do the part on the right. 1 squared is 1. What's s squared plus s squared? 2s squared. Right? You have 1s squared plus 1s squared is 2s squared. Let's divide both sides by 2. So s squared equals 1 divided by 2. Okay, 1 divided by 2. take the square root of each side. So s is equal to the square root of 1 over 2. Do you know the square root of 1? It is 1. Do you know the square root of 2? No, it's a decimal. So we could say that my sides are 1 divided by radical 2, but we would never leave a radical in the denominator. So what we would do is we would rationalize. Rationalize, you multiply the top and the bottom by radical 2 over radical 2. And that will give us 1 radical 2. Radical 2 times radical 2. Well, that's radical 4. And the square root of 4 is equal to 2. So my sides are radical 2 over 2 and radical 2 over 2. Why do you have you do that? Because that gives us what we need to know. That gives us our answers for cosine and sine. Cosine of 45 degrees and sine of 45 degrees. Cosine is the x, which is radical 2 over 2. Sine is the y, which is radical 2 over 2. So make sure those are in your notes. Cosine of 45 degrees equals radical 2 over 2. Sine of 45 degrees also equals radical 2 over 2. Bonus question. What would the tangent of 45 degrees equal? It is sine divided by cosine, right? It is y divided by x, but they're the same. So if I took radical 2 over 2 and I divided by radical 2 over 2, anything divided by itself is equal to 1. Anything divided by itself is 1. All right? Bonus question. Should know these. If you figure that one out, good for you. If you don't, life will go on. So, knowing our 45 degrees, we can find any 45 degree reference angle here. Here's what I mean by a reference angle. We look at the x-axis. That's our 0, that's our 180. And we know this is our 90, this is our 270. This is our 360. Depends on if we didn't go anywhere or if we went a full circle all the way around. So normally we would talk about a 45 degree angle. That would be here. That's that angle. But what if instead I didn't go up 45 degrees, what if I went down 45 degrees? So this is now 45. What's the angle? And when I say the angle, I mean from 0 all the way around would be how far? How could you figure that out? Well, a full circle's how much? 360 minus our 45 degree reference angle. So this is our 315 degrees. Why do we worry about the reference angle? Because I don't want to have to learn a different value for cosine and sine of 315 degrees. I want to be able to say that the cosine of 315 degrees is the same thing as cosine of 45 degrees, but is it positive or negative? That's where those quadrants come into play. Remember, we have all are positive, only cosine's positive, only tangent's positive, only sine's positive. our ACTs. So we get the same answers over and over again. We get radical 2 over 2. We just have to worry about, is it positive or negative? Let's see. 315 degrees down here. Cosine is positive. How about sine of 315 degrees? Well, I know it's still radical 2 over 2. I just have to worry about, is it positive or negative? So 315 degrees is down here. AC. C is positive. That means sine is negative. If I ended up dividing them, try to think of what tangent would be. Anything divided by itself, this divided by this would equal 1, but what if one of them's negative and one of them's positive? So tangent of 315 degrees is now negative radical 2 over 2 divided by radical 2 over 2. Anything divided by itself is 1, but if one's negative and one's positive, that'll make negative 1. So our reference angle here, 45 degrees, means I get the same answers as 45 degrees up here. I'm always making my reference angle in relation to the x-axis. How far up or down do we go from the x? And the same is true if I'm over here somewhere. How far up or how far down do we go from the x-axis? That's called a reference angle. It's my reference point. So we'll try one more. Cosine and sine of 225 degrees. I have to find it though first, right? So 0 or 360, 90, 180, 270. So which quadrant is that 225 going to be in? Well, yeah, it's going to be in between here. The question is, how far from 180 is it? So if I took my 225, and I subtract off my 180, what's my reference angle? Put in your calculator, 225 minus 180, it's 45 degrees. So from 180, always from the x-axis, I want to dip down 45 degrees. There's my reference angle. 45 degrees puts me at 225. 225 is the same thing as 45 degrees. What's sine and cosine of 45 degrees? Radical 2 over 2, radical 2 over 2. We just need to worry about positive or negative. So think back to your A, C, T's, T. T is positive in this quadrant. So that means your negative, tangent is positive. All right, you guys are going to spend a little bit of time working on chapter 9.2, unit circle, 45 degree, 90 degree. And then for homework, Kahoot. See you later, guys. Bye.